All right, we're just going to take a quick look through the contract written in AssemblyScript, and it's in the contract assembly index.ts file. All right, scroll up here to the top. Seem to have a slow computer. Okay, so starting off the contract here, we're just importing some stuff from near SDK AssemblyScript. So contacts, contract batch promise, storage, U128 persistent map, and logging, and we'll cover each of those here in a bit. First thing we're going to do is just define a constant for the contract account. In this case, we've deployed this to, or I've deployed this to access the vitalpoint.a.testnet. Next, we're going to declare a new persistent map called balances, which maps a user's account to their balance, which we're using U128s for that. We could have used I32s or a number here as well, but I just figured I'd use U128 to show some of the nuances involved with working with U128 numbers. Next, we're going to take a look at our enter competition. Sorry, get rid of that. Enter competition function. So like it says here, it allows someone in our competition to send more than 2 near to the contract, and it requires a fullAccess key for that to happen, and it will return true if done. So we declare it as an export, making it visible function, enter competition, returning a bool. We got 2 logging statements here, and these are interesting just so you can see who the context predecessor and the context sender are. Typically, well, you'll see what shows up when you run this. Next, we're going to do an assert statement just to make sure that whoever is calling this is sending enough near with it. We need 2 minimum in order to have it continue. And then an assert statement is like a requirement statement. It's literally, if this fails, it'll throw this error and it'll stop any further execution. Notice U128 greater than, that this syntax for U128 numbers basically says, you know, if context.attached deposit is greater than the U128 number generated from the 2, which is the entry fee, then this will all be true, and it'll carry on. Otherwise, it's going to fire off this error message. We're also going to confirm that the player hasn't already entered. So we do that with another assert statement, basically looking in the balances persistent map, making sure it does not contain the context sender, whoever fired off this function. Otherwise, it's going to say that they've already entered and stop the flow. Next, we're going to actually do the transfer. So that's done with this contract promise batch. So this creates, this is the destination where the money is going to get transferred to. And then we could add a whole bunch of other actions in here, but we have just one, the transfer action. And so we're transferring whatever was sent as the attached deposit with this to this function to this address. So in this case, it's going to be 2 near to the contract. From there, we're going to update the player balance in the balances map. So we're going to call the map, set the address to the amount that was sent to this function, and then we're going to initiate the prize pool if it's not already currently existing, and then we will add what was sent to the contract to the prize pool. So we do that with this, with the storage first we check to see if there's anything at this key right now. If not, then we set it to 0, and then we get the current value that's there, which would be 0 if this is the first time it's called. The new value we're adding, so u128.add, add the current value to whatever was sent into the function, and then we set the new value to that key. So if we call prize pool later on, which we'll do, we'll always get the value, the most latest balance of the prize pool. Moving on to the next function, it's our withdraw winnings function. So this one works similarly to the last one, but when we have a winner, they're going to invoke this function or invoke this method to pull whatever's in the prize pool out and transfer it to their account. So it's going to take one argument in, which is the player calling it. We're asserting that what they're asking to pull out is not any more than what's in the prize pool. And then we do the transfer again, and this time we're sending it to the player, whatever's been asked for, and through the attached deposit. And you'll see when we look through the front end piece here, what we send to here is actually the prize pool balance. So it's basically transferring from the contract to the player the prize pool balance, which is depicted by the attached deposit when calling this one. Next, we'll empty out the prize pool. So we'll grab the current value of the prize pool, set the new value to current value minus this, which will effectively turn into 0 because it's everything, and then return true that it's done. The next function is a reset function, and I've divided this out into 2 pieces here just to show how you can do a private function in AssemblyScript. So what's going to get called from the front end is this one, passing in the 3 players, which will then internally in the contract call the private function, which is depicted by the underscore. And as you can see, there's no export, meaning this isn't being exposed. So it can only be called from within the contract. Takes the 3 players as the arguments, and then it goes into the persistent map and deletes each of the players from the map, effectively emptying it out and resetting the game. And then we got a couple of smaller functions here. First one being steal winnings. All this is doing is setting a value in storage just to make it a change method, and we're just going to use this to see if somebody has access to call it from the front end after we assign keys to them. Same thing with view winnings. This one's not changing anything in state or storage, so it's a view method, and so anybody should be able to call this one. And then we have get prize pool balance, which is also a view method, pulling whatever the balance is of the prize pool. And another view method is entered to see whether the current account is entered in the competition or not. And that is the contract that we're going to use in our application.